Hello, everyone. In support of the U.S. DOT Safety Data Initiative, our team at the Volpe National Transportation Systems Center has evaluated potential safety applications of crowdsourced Waze data. We first developed statewide crash models that provided reliable hourly estimates of police reportable crashes based on Waze events and other roadway information. We then focused on testing safety applications of the methods with state and local transportation partners. Our team collaborated with the City of Bellevue, Washington, to test if Waze event data offers actionable insights to inform their Vision Zero strategies. The Volpe team first compiled an interactive dashboard integrating Waze events, police-reported traffic crashes, and 911 calls related to traffic incidents from NORCOM. In the dashboard, users can filter the crash reports by day of week, by hour of day, or by date range. The dashboard also includes some summary tables showing crash counts by data source over time. The dashboard helps Bellevue transportation planners explore patterns of individual crash reports from different data sources. By including the Waze and the NORCOM reports, they can identify locations where frequent traffic crashes are reported by the public but may not result in a police report. To more clearly identify high-risk roadway segments within the City of Bellevue, Volpe developed an additional set of dashboards to display traffic crashes counts by roadway segments. These dashboards focus on police-reported crashes. The first shows the number of observed crash counts in 2018 on each roadway segment. Users can filter the data by time of day, weekend or weekday, functional class, mobility areas, and by Bellevue's high-injury network. So we can look at all of the segments that are on the high-injury network or all of the segments that are not on the high-injury network. And the high-injury network was developed in a separate study. And if each of these filters were applied, both the map and the chart at the bottom showing crash counts by day of week are updated. The second dashboard shows the same data but weighted by crash severity to highlight the road segments with the most frequent and most severe police-reported crashes, such as the segment of 118th Avenue Southeast. The dashboards that Volpe developed with the City of Bellevue support a variety of traffic safety applications. In the final set of dashboards, we've mapped the camera locations that Bellevue identified as high-priority locations to deploy video analytics for safety monitoring with limited resources, in part using our dashboards. To conclude, the data processing and integration methods that we've developed, along with the dashboard designs, can be adapted to support a variety of traffic safety solutions at other small to medium cities. I'll now turn it over to Dan Flynn, who will demonstrate a statewide application.
Thank you. I'll now demonstrate work that we have been doing with the Tennessee Highway Patrol as a case study partner. The goal is to develop crash propensity models to better guide state troopers to where and when they can have the most impact in reducing crashes or responding to them quickly. We developed a predictive analytics model based on the Highway Patrol's current tool, which uses historical crashes, weather forecasts, and upcoming special events to estimate where and when crashes are most likely to occur. The Volpe team then took that model and added the crowdsourced Waze traffic incident data. First, we applied the predictive analytics model at the spatial and temporal scale currently used by the Highway Patrol as shown in this dashboard. This dashboard allows users to select by day of week, by hour of day and 4-hour time blocks, and by county to zoom in on the areas of most interest. The map divides the state into grid cells of 42 square miles in size with colors representing a crash probability from 1 to 5, with 5 being the highest. The model is based on 1 year of training data and applied to an upcoming week. In this case, we trained the model on data from spring 2018 through spring of 2019 and applied the model to an upcoming week in May 2019. Selecting Davidson County, where Nashville is, we can see some of the details. Each grid cell shows the maximum crash probability in the selected time period by hour, with additional details on the variability. Next, we use the same input data, historical crashes, weather, special events, and the crowdsourced traffic incident reports from Waze, and applied it to finer temporal and spatial scales. This dashboard shows the results at a 1 hour and 1 square mile resolution. This model had very high accuracy over the 1 year training period, and likewise, we applied it to one future week in May 2019 for this demonstration. Again, selecting Davidson County, we see some more detail on the hour-by-hour variation in the crash probabilities. Within a day of week, you can also see the hour-by-hour variation zoomed in for a particular hexagon. We are continuing to work with the Tennessee Highway Patrol to transfer this model to their operational work.